Hello and welcome, MEGN 200, to a lecture about getting you up and running with your Arduino kit. This is Professor Wheeler. I just decided to make you a video that will hopefully get you up to speed connecting to your Arduino and get you writing your first code that you can execute on the Arduino. So without further ado, let's go ahead and jump into that. All right, so my goals for you today are for you to explore your Arduino kit. Make sure that you're bringing these to class with you each and every day because we'll be using them throughout the entire class. And I want you to start understanding basically what your Arduino can do and how you use the Arduino IDE to program your Arduino and make it do what you would like it to do. All right, so first of all, let's talk a little bit about your kits. Remember, these are yours to keep. So at the end of the semester, you get to take these with you. You can write your name on them, do whatever you want with the components. Just make sure that you're holding on to those and bringing them to class every day. A lot of students also like to hang on to them after the class is done and then reuse them on in later classes, whether that be MEGN 300 or 301 or any of your other classes where you might have an automation component to them. The Arduino is a very handy tool to do that, and you've already got one in your hands now. All right. So what exactly are we working with when we're working with this kit? The primary component that we're going to be playing with is your Arduino. And the Arduino is a type of microcontroller. So generally a microcontroller is a small computer. It is not as powerful as, like, say, your laptop or even your cell phone, but what it does is it can execute small blocks of code reliably, and it's got a lot of interfaces that it can use to talk to the outside world. Okay, so the way that we talk to our Arduino and get it to execute code is we first have to write the code and write our software and then upload that to the Arduino, and then the Arduino itself will take that code and execute it and do whatever instructions we've given it. So to do that sort of programming, we need some software that we can write the code in, compile the code, and then send the code over to the Arduino. And so that comes free with an Arduino. If you go to arduino.cc, go to their software download site, and we've got a link there in the video, and I'll put a link down in the description below as well. You can go there and you can download the Arduino IDE, which is what will be used in programming our Arduino. And there's different versions of this depending on what operating system you're running on. So Windows, we've got the link highlighted there, and we also have Mac OS options available to you as well. If you're programming in Linux, you probably don't really need my help to install the IDE. You've probably got that figured out already. And if you are on a Chromebook, there is an online editor which will work for most things also, and you can find a link on that same page to get to the online editor. All right. So what exactly is an Arduino and why are we using it for this class? So Arduino, as we mentioned, is a microcontroller. So it's a computing device that's enabling your software to interact with the physical world. So if you think about your laptop, it's a very powerful computer, but it's not really designed to connect to the physical world very well. Like if you wanted to read the temperature in the room that you're in, laptop doesn't have an easy way for us to hook up a thermometer to it and start really collecting data. We'd have to buy some components that were reading a sensor and then sending information over to the laptop. A microcontroller, on the other hand, is designed to do exactly that kind of task. Some places that you see microcontrollers, cars. Cars are a huge field where microcontrollers are found. A typical modern car will have at least 50 of them. So things like the engine control unit that are measuring how your engine's running and controlling the fuel air mixture going into your engine. That's an example of a microcontroller. There's also microcontrollers that read your wheel speed of each of your wheels individually, and they'll detect that if your car is starting to go into a skid and pulse the brakes for you. So that's how your analog brake system works. There's microcontrollers looking at how your wheels are spinning, and if it detects that you're starting to get into a skid, it'll correct for that behavior also. So the Arduino is a type of microcontroller that we can use. And one of the cool things about Arduino is that it is a fully open source platform. So all of the software is open source, but also all the hardware is open source. So anyone who wants to can download the plans to make an Arduino board, and you can construct your own. If you'd like to do that, it costs about $3 to $5 in components, and you can solder together your own Arduino and program it and get it up and running. So part of the reason that I want to bring up that this is open source is that sometimes you'll see Arduino boards that are made by different manufacturers since they are open source. So this is the official Arduino, which is blue, and it has that nice infinity symbol on it. You'll also sometimes see a red version of Arduino that's made by a company called SparkFun here locally. And then the one in your kit is an Elegoo Arduino based clone. It works exactly the same way. They all just have a slightly different appearance. So yours is black instead of blue, but all the pins are in the same location, and they do the same things as the official Arduino. All right, where exactly does the name Arduino come from? It's actually named after a bar where the original inventors of the Arduino like to meet up, and they named the Arduino after their bar. So there's a little bit of the story about the bar being named after a king of Italy. Arduino is originally from Italy as well. It's an Italian invention, and there's a little bit of fun fact trivia for you. Okay, so why exactly do we use this microcontroller? So the microcontroller enables our code to read sensors and then control an actuator. So a sensor would be some piece of hardware which is collecting information from the physical world, and an actuator is something like a motor, a relay, a light, where we can have an output that goes out into the physical world as well. So this is really why microcontrollers are really special. Is if we want to control a mechanical system, a microcontroller is the computer that allows us to do that. So we'll see a lot of microcontrollers in places like 3D printers, CNC machines, so that's computer numeric control machines, like the sort of robotic milling machines that are down in the machine shop, robots, drones, all over the place. Anytime we have some sort of mechanical system that we'd like to have software execute inside of that mechanical system and the software affect the operation of the mechanical system, microcontroller is generally involved in that type of design problem. Okay, Arduino is really cool. Also, it's been around a while, and it has a really extensive, very broad online community with a lot of people active in it. So there's lots of support for problems that come up. There's lots of code that we'll be able to download and reuse, modify for our purposes, and libraries. So if there's a specific set of functions we'd like to use, we can generally find a library that somebody's already written, be able to download those and use those functions and extend our project that way. We do have a link, which I'll throw in the description down below, to 10 example Arduino projects, just to sort of whet your appetite and show you what's possible with the Arduino. All right. When you're looking at your board, so again, this is the red version of the Uno, but it's exactly the same as the black one that you have in your kit. All the pins are in the same location. This is what you're going to see, right? There's different types of pins depending on what we're trying to connect to and talk to. So up top in this slide, you'll see that we have some digital pins. So this is if we have a strictly sort of on-off signal that we want to either read or send out. So if we wanted to read the state of a button, so see if a user is pressing a button on our device, we could use one of those pins to see if that button is being pressed. We could also send out signals to turn on a light, which is what we'll be doing today. And if we could turn on a light, we can also turn on things like a motor or any other device that we might need to for our project. Okay, down below we also have some analog pins. These are strictly inputs, so when we want to read a signal that's not a strictly on-off signal like a button, if we wanted to read, say, a temperature from an analog thermometer, we can do that using those pins down there. And then we also have some power pins. So as we get more complex circuits that are requiring more power to operate different devices, we can pull power from those pins down there and have access to that. All right, so at this point, I think what we should do is we should jump over and we take a look at your Arduino, and we'll look at the Arduino IDE, and we'll talk about how do we get the Arduino IDE to talk to the physical Arduino hardware, and we'll write our first program and upload that to the Arduino and start actually controlling that hardware. So I will meet you over at the electronics bench. All right, so here we are with our Arduino out on the bench. Currently, it's just sitting here by itself. It's not powered up or anything, so it's just off at this point. So again, as we talked about in the slides, we have our digital pins up top. This is where we could read buttons. We could turn on and off lights. We have analog pins down here if we have to read some sort of analog signal. And we have our power pins where we can connect different devices and power them that way. today what we're going to be focusing on is that there's actually a built-in LED right here that is connected to digital pin 13. So you see there's a pin labeled 13. If we connect something there, we can turn it on and off using that pin. And the creators of Arduino have also given us a nice LED that's soldered onto the board. So whenever we turn on pin 13, this LED is going to light up also. That's just a handy fact if we are troubleshooting to have that LED right there. We can essentially tell it to turn on and off, blink on and off, and we'll see if our Arduino is working and if we're able to upload code to it. Other things that you'll want to pay attention to is right below this pin 13 LED, there's two other LEDs. This one's labeled TX and the one below it is labeled RX. Those are the transmission and receiving LEDs. So those indicate if we have activity coming in through our USB port. If information's being exchanged through there, you're going to see those LEDs light up. So we'll watch when we decide to upload our first code to the Arduino. You're going to see these LEDs blinking back and forth as the Arduino is reading in data from the computer and getting that loaded into its memory so that it can start actually executing code. So with that, what we can do is we can plug this in and we'll show you what it looks like when it powers up. So to power up the Arduino, all we have to do is plug it into USB, and it's going to pull the power it needs over the USB port. And so we get a power LED that will turn on once we have that, and our pin 13 LED is blinking. Now this doesn't necessarily happen every single time you plug in the Arduino. It depends on what code has been loaded onto the Arduino, because as soon as it gets power, it's just going to start running whatever code is in its memory. And Elegoo, our manufacturer, happens to test all of these boards at the factory by uploading a code which tells pin 13 to turn on for 1 second and then turn off for 1 second, and it just blinks that pin 13 LED over and over and over again as long as the Arduino has power. So that's what we're seeing here today. So what I'd like to do is we're going to write this example code from scratch, and we'll modify how quickly this LED blinks, and we'll show that we're able to control the Arduino and get code uploaded to it. So from here, we're going to jump over. I'm going to open up that Arduino IDE, which hopefully you've downloaded, and we will write this program together from scratch, and we'll show you how all of that works. We're into our code. You should see something like this, and this is what we call a blank sketch. So a sketch is just what we call a Arduino program, just a set of instructions that it's going to run. And all of our Arduino sketches have this basic structure to them where you get two functions declared automatically. So the first function right here is what we call setup. And setup runs once the Arduino powers on. So in setup, typically what happens is you tell the Arduino which pins you're going to be using, if those pins are inputs or outputs, like if you're trying to collect information from the world, if you're trying to send signals out. That's what we're going to be declaring in there. And then there's this second function called loop. And in loop, we give the main body of the instructions that we want the Arduino to execute, and it just runs loop over and over and over and over and over again until it loses power. So it's just an infinity loop that runs forever until the Arduino loses power, and then it shuts itself down. Okay. Up before either of these, you can also declare global variables. So if you declare a variable up here, it's going to be available in both the setup and the loop functions. So for what we would like to do is we want to recreate this program that's running on here that's telling the LED to turn on, wait a second, turn off, wait a second, and then turn back on, and just repeats that over and over again. So we're going to go ahead and write that example, and then we'll change our delay that's happening inside of there, and we'll get the LED to blink faster or slower, whatever speed we want it to blink at. So to start off with, I'm just going to give us some comments. So a comment in Arduino is just like they have right here with 2 forward slashes is how you make one. So I'm going to go ahead and do that. And the first thing I'm going to do is declare a variable. And this is going to store the LED pin. All right, because the pins have different numbers, and in our case, that LED is attached to pin 13. here on the board. So what we would like to do is just store that number 13. So say if we wanted to use this code again, but we wanted to physically attach an LED somewhere else to one of these other pins, we could just change this one variable and the change would propagate through the whole sketch and we wouldn't have to recode the number 13 like if we hard coded it in there. Okay, so that will be our first step. Once we've done that, then we need to come into our setup and we need to tell the Arduino that the LED pin is going to be an output. So we're not trying to read information from the LED, we're trying to control it. So that means that it's an output. Okay, so we will set that up and then we'll be ready to go into the loop where we're going to have our instructions that repeat over and over again, and we'd be ready to set that up as well. So the first thing we want to do is turn the LED on. And then we're going to wait for some amount of time. And then we're going to turn the LED off. Right. And then finally, we're going to wait a little bit longer. All right, so we'll turn on, wait, turn off, wait, and then we should get this behavior where we see the LED blinking on and off repeatedly because this loop function just repeats for as long as the Arduino has power. Okay, that's the basic structure of what we would like to do with this sketch. So now that we've got our basic pseudocode comments in here, we can go back in and we can actually put the real syntax in. So we'll start off by declaring this variable that's going to store the LED pin value. In Arduino C, you do have to declare your variable types. So it matters whether you're storing an integer or a string or a double with a decimal place. We have to tell the Arduino what kind of value we want to store in this variable. In our case, we're just storing a number with no decimal place, so I'm going to use an integer, so that's int. And then our variable name, I'm going to call it LED pin, and we'll set that equal to 13 because, again, pin 13 is the one that has our LED attached to it. All right. From here, we are good to go and start putting in our setup. So in setup, we need to set up our LED pin as an output. The way we do that is there's a function called pin mode with a capital M in the middle of it. When you get the syntax right, it will highlight like that. So if you don't see that nice orangey color popping up when you type in pin mode, probably means you got a spelling mistake or possibly a case mistake. So Arduino is case sensitive, so be paying attention to capitalization in these function names. And the pin that we're going to be setting up is LED pin. And the mode, which you separate with a comma, is this is going to be an output. Okay. So we've just told the Arduino that that pin is not going to be an input. We're going to be sending a value out from there. And that's the only pin that we're going to be using. So we should be good to go into our loop and start putting in the instructions that tell that LED to turn on and off. All right. So first thing we want to do, turn the LED on. Okay, this we can do with the digital write function. So digital write will write like a true false value to a pin, which is translated as a voltage. So true is 5 volts and false is 0 volts. So if we want to turn a device on, we just say write digital write and we say either high or true is the value that we want to write to that pin. And that will set 5 volts as our output. So let's go ahead and write to LED pin. The value we want to write here is high, which equates to our 5 volts, which should turn the LED on. Once we've turned the LED on, we want to wait. Okay, so we want the LED to be on for some period of time, and then we're going to turn it off after that. And we accomplish that with the delay function. So delay, we give a number of milliseconds that we would like it to wait before we go on to the next instruction. So it's just going to stop the code right here. Nothing else is going to execute while the delay is happening for however many milliseconds we put in between the parentheses. So 1,000 milliseconds is equal to 1 second. So we'll go ahead and start with that as that matches what we're seeing from our factory example over there. And then we need to turn the LED off. It's going to be the same command as before, digital write. We're still writing to the LED pin, but now we're turning it off. So we're going to set that pin to low, which will set it to 0 volts, and our LED should turn off. And then the Arduino does execute very quickly, so if we just end it right here, what would happen is it would turn on, wait a little bit, turn off, and then immediately jump up back to the beginning and turn back on. So we wouldn't actually see the LED turn off, because it would go from turning the LED off to turning it back on again so quickly we wouldn't actually see that with our eye. So we need to tell it to wait a little bit again. So we'll tell it to wait for that 1 second. All right. So at this point, we are ready to go ahead and see if we can get this code running on the Arduino itself. To do that, there's a couple of buttons that you can use. So first one right here is verify. If you hit that, it's going to try and compile the code. So if the code compiles, that means we don't have any syntax errors, and you'll be able to that code should run on the Arduino no problem. It has all the resources that it needs. And then the second key with the arrow is the upload button, and that is what's actually going to try and send the code over to the Arduino. So I'm going to go ahead and hit upload. Uploading also compiles for you also, so you don't have to do verify then upload. You can just hit upload and it will do all the steps necessary for you. And you should see down below it's giving us that message saying compiling the sketch. So it's translating our code that we've written into machine code, so ones and zeros. That is going to be then sent over the USB port. And once it's done compiling, we should see the USB port kind of light up. It's taken a little bit of time to compile today. All right, here we go, uploading, and you can see those TXRX lights lit up. All right, and we get the message over back in Arduino. It says done uploading, and we get a nice clean message here that's saying that it uploaded the file with no problems. If you get red text down here, that typically means that there's some sort of problem uploading the sketch. You might have to disconnect the Arduino and try again, like unplug it, plug it back in, try again. But that is the basics of how you get a code up and running. So we can see now we're blinking, and we are getting the behavior that we wanted, where the LED is on for 1 second, then off for 1 second. But granted, that was what was on the Arduino when we started. So let's see if we can change this delay number. So instead of 1,000, let's do 500, so it should be half a second. We'll change both of those. And if we re-upload this, we should see the LED blink twice as fast. So again, we have to go through compiling and uploading. Here we go, it should upload again. Here it goes. And now we're blinking twice as fast. So your worksheet is going to ask you to try varying that value and seeing when we actually lose sight of being able to see the LED blink. All right, everyone. That's how you get your Arduino code up and running for the first time. So hopefully you've been able to get that working. If you do have any problems, come see us during office hours. Anybody, any of the instructors, me, Amanda, any of the other TAs or instructors would be happy to help you out and make sure that you get your code up and running. Sometimes there are some things like we have to update drivers or whatnot to get your computer talking to the Arduino, but that should not be a problem. If you do have some issues, come see us and we'd be happy to help you out with that. Just to give you a heads up of what's coming on, today we just kind of talked about intro, like how do you get the Arduino connected to your computer, software installed, and get your code running on an Arduino. Next week, what we're going to be coming back and doing is we'll start working on our first Arduino worksheet, where you get to explore more in depth how you interact with the Arduino programming language and get some hardware set up around your Arduino and control that also. Okay, so the way that it's going to work is individual assignment. You answer questions, and there will be places where it asks you to record a video. So to show that it's you, show us your circuit, and your code all working together on a short little video, and that's how you get credit for doing those activities. We do have an Arduino e-textbook that is our sort of modified version of the book that came with your Arduino kit that we kind of refine every semester. That's linked in the assignment also, so there's some great tutorial information that you can follow along with there if you want to start working ahead on that. All right, just as a recap, today what we did is we hit out your Arduino kits, made sure that everybody has one of those, and we start to see what components are in there. And next time we're going to start to work on circuits that involve some outputs and inputs, and we'll talk more about how you can use the Arduino to take control of those, and we'll start working on your first worksheet. Again, if you have any trouble at all or you want some help, want to talk about Arduino, we'd love to see you in office hours, so do check those on Canvas and let us know how we can help you out, and we'll look forward to seeing you again soon. Thank you.